All right, so today we're going to talk about some other types of sampling. We're going to talk about biases, how they can hurt studies, how they can occur, what types there are. So we got a lot to go through in a short amount of time here. First, sampling types so far. We talked about SRS. With an SRS, we take our sampling frame, we label each of the individuals, making sure those labels have the same number of digits for each one, and then we just randomly select. So each person within the sampling frame has the same chance at being selected for the sample. With stratified, that was the second type of sampling we talked about. In stratified, it was basically taking an SRS, but what did we have to do first? Separate the population, okay? So if we felt there were fundamental differences within the population, we would separate into separate groups first, and then do an SRS from each of those groups that we created. So we might create 4 different groups, group A, B, C, and D. We would take an SRS of group A, SRS of group B, C, and then also D. So at a stratified sample, we separate first, and then we do an SRS of each. We're going to talk about a couple more types of sampling that may make things either more convenient or they might make things more practical anyway. So options that you have as far as collecting samples. So first thing, just kind of thinking through an example here. Suppose we wanted to assess the reading level of our textbook based on the length of the sentences. What problems might we run into if we wanted to take an SRS? What do you think? If we wanted to find a sample of sentences out of our textbook, why would an SRS not necessarily be the best choice here?
Depends on how much math you're interested in.
Well, in this case, we're not worried about the complexity of the sentence. We're only looking at the length of the sentence. So based on the length of the sentence, that'll tell us the level that this book happens to be at. So it's not necessarily that. What with the sampling itself would we run into issues with? So selecting our sentences, why would an SRS not necessarily be our best choice? Okay.
There would be thousands and thousands of sentences in this book that's not fitting.
Yeah, if you're thinking about our book here, how many sentences are in that book? Thousands and thousands, right? Which means you have to go through and label every single sentence with a value, right? And even after you get it all labeled, then you have to start picking out random values. And once you have those random values selected, you have to scroll through that book and find that specific sentence. So you might have 15,000 sentences in your book, and your first sentence that you have to find is 3,766. So you have to flip through your pages until you find sentence number 3,766 and use that sentence, right? So it's going to take a long time, not only to label, but then even once you have them labeled, to find them and analyze them. So an SRS might not be our best option. So a solution would be to pick a few pages at random and just analyze the sentences on those pages. So we have 500-600 pages in the book. We could randomly select 10 of those pages. So any 10 pages, real easy to find a page, right? Just flip to that particular one, you're there. And then use that page and just look at all the sentences on that page. So rather than sitting there and labeling every single sentence and then having to find each of the individual sentences and analyzing them, this method allows us to find a page very quickly and then just analyze everything on that page. Okay? Now, one thing to be wary of here, we need to make sure that when we select our pages, we should believe that each page is fairly representative. So we wouldn't expect, or we wouldn't want to necessarily find a page that has way fewer sentences than all the rest, or way more than. We would want to believe that if I choose a page at random, I'm going to essentially get a representative page. All the pages should be similar to one another. Does that make sense? Okay? So this type of sampling is what we call cluster sampling. So we had SRS, pick at random, stratified, which was separate and then pick at random. And now we have cluster. With cluster sampling, we are going to take groups of our population and choose them at random. So we're going to take our population and divide them into groups and select some of those groups at random to be part of our sample. Now, with this cluster sampling, one of the things we have to be careful with, in order to use cluster sampling, we need to make sure that the groups we create, so when we take our population and separate them into different groups, each group we create should be representative of our population. So if I separate it into 5 different groups, I need to make sure that group 1, group 2, group 3, group 4, and group 5 are all individually representative of the overall population. So when we think about this, we're grouping our population again, which sounds a lot like stratifying. But with stratifying, why were we grouping? Why did we take our population and split them into groups with stratifying? What was our purpose there?
Is it because the groups like weren't even necessarily?
Well, because they weren't necessarily even, but they also weren't, or we felt that the groups were different from each other. Group A was different than Group B, and Group B was different than Group C. So we were separating based on differences, right? Whereas here, we're separating simply based on practicality. When we separate into our groups from one to the next should be similar. Group 1 and Group 2 should be almost identical. Group 3 should be almost identical to those, and so on. So it's a little bit different. We're going to get into those differences here a little bit more in a second. But that's what we're doing with cluster sampling. So here's another example. There's an example from your book. I think they talk about the University of Texas. So pretty large university. And they say freshmen are all housed in 10 different dorms. So the problem was they wanted to gather some information about freshmen at University of Texas. Now you could do an SRS, so you could get a list from the college of all enrolled freshmen, but you'd run into the same type of problem that we ran into with our sentence problem. You have thousands upon thousands of freshmen at University of Texas, right? So you'd have to label every single one of them. And then, once you got them labeled, you have to select them. And once you select them, then you got to go hunt them down, right? So you got to find out where they live, you got to find out how to get a hold of them or whatever. So it's a lot of stuff that you just probably don't have time for. So an easier way to do it is to notice that, well, at the University of Texas, they house all of their freshmen in specific dorms. So there are 10 dorms designated specifically for freshmen. Well, so if I want information from freshmen, what I could do is label the 10 dorms. Label them 1 through 10, or label them 0 through 9. And then all I have to do is select maybe 2 or 3 of those dorms. So dorm number 4, dorm number 8, dorm number 0. Okay? And then I can go to each of those dorms and ask all the freshmen inside. So go to dorm 0. Knock on all the doors. Ask everyone that answers what their opinion is. Go to dorm number 4. Knock on all the doors. Ask everybody what their opinion is, and so on. You see how that kind of saves us some time as far as sampling. And if we think about it, should each of those freshman dorms, so should each of those 10 dorms more or less be similar to each of the others? So would dorm 1 be similar to dorm 9? Should be, right? So if they're all just freshman dorms, each dorm building should be pretty much similar to all the rest. Now, in some cases, what you might be concerned with is there are colleges that sometimes have dorms based on sport. So if they separate based on sport, you might have to take that into account, okay? But if we're assuming that each of the dorms are made up of about the same type of students, you'd be able to use this cluster sampling.
If they had dorms like by gender, would you have to stratify them in cluster, or is that not something you do?
You would only have to stratify if you felt men and women would have a difference of opinion on the matter. If you didn't feel like there was any difference between men and women, you wouldn't have to worry about that. You can just pick your dorms and go. Because the men and women should answer about the same either way then. But yes, if you thought there was a difference, then yes, you'd have to separate into men and women dorms, then take for each. Yep. So we go with that idea? All right, now, before we move on to the next type, I really want to make sure we understand the difference between stratifying and cluster, because these are the ones people mix up the most. So cluster sampling is not stratifying. There are some major differences that occur when we select our samples based on stratifying and based on cluster. So we stratify to ensure that our sample represents different groups within the population. So we are separating our population first into different groups. Group A is different than Group B, is different than Group C. So we want to ensure that our sample has individuals from Group A, individuals from Group B, and individuals from Group C. That is a must. We have to have that to make our overall sample representative. Okay? So the big thing here, the groups we create when we stratify, internally are homogeneous. That means internally in Group A, all the individuals in Group A are pretty much identical. All the individuals in Group B are pretty much identical. All the individuals in Group C are identical. Okay? So internally, each of the groups should be made up of the same type of individuals. But from one group to another, they should be completely different. Group A should represent a completely different portion of our population than Group B does, which would represent a different portion of our population than Group C, and so on. Does that make sense? So that's stratifying. We're separating based on differences and then selecting from each of those groups. Okay? Cluster sampling. When we create clusters, we are separating into groups still, but this time, Group A should be almost identical to Group B, which should almost be identical to Group C, which should almost be identical to Group D, however many groups we actually have. So from one group to the next, they should all be fairly representative of the entire population already. So it's almost like you're taking your population and breaking it into little mini populations that you're going to select from. But inside the group should be a complete mix and match of individuals. Group A should be filled with different types of people. And those different types of people or individuals should be representative of the entire population. Group B should be filled with a mix and match of individuals, all of which should represent the overall population. Okay? So with cluster sampling, we are grouping still, but some of the main differences are not only how we group, but then what we do with those groups. With stratified, we separated into groups, and then we took an SRS from each group. So an SRS from Group A, SRS from Group B, or B and then C, and those become our sample. When we cluster, we take our groups and we randomly select the groups. So if I have 10 different groups that I created, I'm only going to select maybe 2 or 3. And those groups that I select are my sample. So I go to Group A, and I ask every single person in Group A. I take a census. And then I might choose Group G. I go to Group G, and I take a census. Every single individual gets measured or asked. And then the same thing. It's just the same process over and over. So with cluster, we choose the groups, and those are our samples. We have to take everybody or every individual within the group as part of our sample. So stratified, separate into groups, SRS from each group. Cluster, separate into groups, choose the groups, and take a census. So you're not going to go to every single group and pick. You pick only a few and use those guys as your sample. Does that make sense? For the most part? Okay. Next type of sampling that you can use is called systematic. Systematic is pretty straightforward. So you take a sample and you draw that sample systematically from a list. Now, what do I mean when I say systematically? So I defined a word with the word, right? So systematic sampling. What we mean by that is selecting every 10th person down the list, or maybe every 3rd person down the list. You might select every 100th person, depending on how big your list is. So systematic sampling is you're choosing every nth individual in a row. So if we think about that with our book page problem, a way to not have to worry about a complete SRS is we might just say, well, I'm just going to start going through the book page by page, and I'm going to select every 100th sentence for my sample. Now that's still going to be a pain, because after I take whatever I start with on my first sentence, I have to count 100 sentences, and then I'm going to select the next one. And then I have to count 100 sentences more. So it's still not necessarily practical for it, but it could be done. Okay? You might ask people's opinions of a concert as they're leaving the concert. And so what you might do is you might randomly select the first person, and then from there, every 20th person that comes out the door, you pull them aside and ask the question, or ask their opinion. So anytime you're picking every nth person from a list, that's systematic sampling. Okay? Now, with this, you still have to employ randomization. If I'm only selecting every 10th person, that's not really random. Okay, that's a system that we've set up. So to randomize with systematic sampling, you have to select your starting point randomly. So if you have a list of 100 names, and you wanted to select every 10th name on that list, you still need to have a random starting point to begin with. So to do that, you might take the first 5 names. So the first 5 names on the list and label them 1 through 5, and then just generate one random digit from 1 to 5. So either on your table of random digits or in your calculator, whatever number from 1 to 5 comes up first, that's your starting point. So if it was the second person, you would start with person number 2, and then every 10th person after that. So then the 12th person, then the 22nd, and so on. Does that make sense? So with randomization, you're still employing it by choosing your starting point randomly, and then using that nth person selection. Now with systematic sampling, you just need to make sure that the order that your list happens to be in won't affect the outcome of your sampling. Okay? So, for instance, if you're looking at a football team, so if you had a football team and you had your list by jersey number, so jersey number 1 through 99 or whatever they have, okay? So if you were to do that and you were to randomly select every, let's say, 20th person, so you didn't need a large sample, you said, I'm going to select every 20th person, okay? For those of you who play football, how are those jersey numbers arranged?
Like the lower numbers are usually like the skill people or the people in the back, and then like 50s, 60s, 70s are usually linemen, then above that are usually like kickers or receivers.
All right, so positionally, you get a jersey number. For instance, linemen, centers, guards, tackles have to have their numbers within a specific range of jerseys. They have to be from 50 to 70s, right? So if I was picking every 20th person, so if I'm looking at a jersey number and I'm picking every 20th person, I might completely miss an entire position on the team. right? I might miss pretty much the entire offensive line, which might mess up my findings for the overall study that I'm looking at. So in that particular instance, the order of the list would affect the types of people I would be selecting from the group. Does that kind of make sense? So if you can look at that order of the list and say, okay, well, if I'm selecting every 10th person, I see a problem with this, then you can't use systematic. But if the order of the list has no effect on the types of people you'll be selecting, systematic is always an option you can use. We okay with that? All right. We just talked about this a little bit ago. Randomization, still utilized by picking a random starting point. So that's a must. If you're going to use systematic sampling, you have to select your starting point randomly, and then you just use that every nth person or individual for your selection. Okay? Last good type of sampling is what we call multi-stage. And multi-stage sampling, basically what it boils down to is a combination of two or more of the sampling types we just talked about. So in multi-stage sampling, we might use two or more of the different sampling types. We might use, so we have SRS, we have stratified, we have cluster, we have systematic. So we might use any combination of those. So you might choose cluster sampling, so you're going to choose to cluster. So let's say the freshman dorms example at Texas. You might choose 3 of the dorms at random. Now, if those dorms are large themselves, maybe you don't want to go to every single door within that particular door, or those 3 dorms, and ask all the freshmen. You might not have time for that. So maybe what you do is after you cluster, so you select your 3 dorms, maybe instead of a census, you perform an SRS. So in this particular dorm, I'm going to select, and then you go through and randomly select what doors you're going to stop at. And then the same thing for the next, and so on. So there you're combining cluster sampling with an SRS. That would be multi-stage. You can do stratified with systematic. So you might stratify group A, group B, group C. And then within group A, you might randomly select every 10th person. And then in group B, you might select every 15th person. And in group C, you might select every 11th person or whatever. So that would be a stratified sample with systematic combined. That's what we talk about when we talk multi-stage. Okay? So most surveys conducted by professional polling organizations, you don't have to necessarily write this down, they use some kind of combination with stratified, cluster sampling, as well as simple random samples. So most professional sampling that you'll see will use a combination because they're dealing with such large populations, they generally have to break it down in different ways. Okay? All right. So now let's switch gears. Those were good things. All of those sampling methods we just discussed, those are good sampling methods. They should lead to good samples, which will be representative, which will lead to good results. So if you see a study done and they show that they used one of those methods we just talked about, their findings should be pretty reliable. Whatever information they're giving you, you can be pretty sure that it's going to be representative of the population and it's probably information worth working with. Now, biases. Biases occur in many different ways. We're going to talk about a bunch of different types, but we're talking about when the design of a study systematically favors certain outcomes. So basically a bias is something that gets into the study that just messes up the results somehow. So it makes whatever was supposed to be reliable findings unreliable. And these things can happen in even the most well-designed studies. There are just times where things happen that are outside your control, and so they can kind of creep in anywhere. So let's talk about the different types that we can run into. The first type of bias that we can run across that causes issues is what we call undercoverage. With undercoverage, what happens is our sampling method produced a sample that missed key components of our population. So undercoverage occurs whenever our sample is missing key components of our population of interest. So if we think back to our example from a couple days ago with Stratify, we feel that men and women might differ in opinion on funding for the football program. Now, if I took an SRS and that SRS produced an entire sample of men, our study would suffer from undercoverage because women are completely underrepresented, which means we don't have a representative sample. We are missing a key component of our population. So undercoverage is any time you produce a sample that is missing part of the population. Okay? Another example, U.S. household surveys. When they send stuff out to households, they are missing prison inmates, sometimes students in dorms don't always get that information, and the homeless. So if your population of interest are all U.S. adults, for instance, and you send out a U.S. household survey, you're possibly suffering from undercoverage because you're missing key components of your population. Does that make sense? So that's undercoverage. You're missing pieces based on your sampling method. Okay? The second type is called non-response bias. This one's pretty straightforward. Non-response bias is selected individuals refuse to cooperate. So you might have gone through your sampling frame, you collected an SRS, you go out, you start asking the individuals that you selected for your sample your particular question, and they just tell you, nope, I don't want to do it. I refuse to cooperate. I don't want to answer your question. I refuse. That's non-response. You send out a questionnaire, and so you send out 10,000 questionnaires, and 150 come back. That would be non-response. Okay? So with non-response, selected individuals are refusing to cooperate. Now this is a a bias that's unique to human beings. So when you have human subjects as part of your sampling, you can always run into this particular type of bias. But human subjects are the only ones that can contribute to this type of bias. Now, one thing to note here, when we talk about non-response bias, we're not saying that, okay, I had a sample of 50 people, I went out, and 48 of them answered. So 2 of them said, I don't want any part of this, leave me out of it. That's not non-response bias. Okay? When we talk non-response, we're talking about a fairly large percentage of your sample is refusing to cooperate. So if you went out and you had 50 people you were supposed to question and only like 15 of them answered, now you're probably suffering from non-response. Because what's happening is the people who didn't respond may have differing opinions than the people who did, and we won't know that because we didn't gather those people's opinions. So with non-response, the question we have is, are the people who didn't respond differing than the people who did? Now, if we're only missing a couple people from a sample, that's not going to affect our overall findings much. But if we're missing 30, 40, 50% of our sample, now we might start having some issues. Does that make sense? So when we're looking at non-response, it's not because a couple people didn't answer, it's because lots and lots of people didn't answer. The next type is called response bias. Now with response bias, this one's kind of vague in that it can be a couple different things. Essentially what it boils down to, response bias is anything that can affect the response of the subject. So for instance, behavior of the subject or interviewer can bias responses. if I was going around collecting information from you guys, and I was asking you certain questions, your opinions on different matters, if you're in a bad mood versus when you're in a good mood, might your responses change? Absolutely. Depending on how we're feeling that day affects how we respond and how we interact, right? Same thing with the interviewer. The way I ask a certain question might influence your responses. Should kids really be allowed to just stay home sick if they only have a common cold? Okay? If you get right up on them, you say things and you have a tone to it, that can influence responses. So even if she agrees that students should be able to stay home if they're sick, the fact that I'm pressuring or persistent on it might force her to answer a different way. Okay? So the way you ask a question might sometimes affect it. So the tone you might have. All right? Another thing that can happen is lying. Again, subject or unique to human subjects. Humans have the ability to lie. And in a lot of cases, they will lie if they're asked about illegal or illicit behavior or things that might be deemed socially unacceptable. Okay? So, for instance, if you were to ask people, do you wash your hands after you go to the bathroom? What are most people going to say? Yes. Now, hopefully that means most people wash their hands after they go to the bathroom. But from experience, have you seen people use the bathroom and not wash their hands afterwards? Absolutely. But if you ask that person, of course they're going to say yes. If they say no, that's gross, right? So they're going to lie. They're going to make themselves look better because they know that the alternative isn't socially acceptable. Now, some people won't care. They'll just flat out say, nope, I don't care. But most people will sometimes lie to avoid that social awkwardness. Does that make sense? Also with illegal behavior, most people aren't going to fess up, hey, have you ever tried pot? Okay? Most people are going to say no, especially if it's to an authority figure. If I walked around and said, hey, have you guys drank before? Most of you are probably going to say, no, I haven't. Right? Even if you have. I'm not saying any of you have or haven't. I'm just saying you're going to say no probably no matter what. Right? Because it's an illegal behavior, you don't want to get in trouble for it. Interviewer attitude, like we talked about. Interviewer, the tone of voice, the vibe you're giving off, the nonverbal cues can play a role in how people respond. The last one here, and we'll pick this up when we get back from lunch, but I want to finish response bias before we break. It's what we call telescoping. Telescoping is when you ask people to recall from memory. If you ask them to recall an event from memory, memory is often extremely unreliable. You can have 10 different people witness the exact same event, and all 10 people might have a completely different account of what happened. When you remember things, you are not always remembering exactly what happened. You'll have gaps that your brain will try to connect with whatever would most logically make sense to you. So when you ask people to remember things, more often than not, you're going to get unreliable information because no one remembers everything exactly. The only people who do, I think they call, I forget what the correct term is, but it's called perfect memory, essentially. So there are people who literally remember every single day, every single minute, every single second of their lives. You could ask them at exactly this time, on this date, what was happening. They could tell you every single thing down to the last detail. But it's very rare. So for most humans, when you ask them to recall from memory, you're going to get unreliable information. So that would be a response bias because their memory is affecting how they respond. Does that make sense? All right, go to lunch. We'll pick up where we left off. So then, our next one we have to be careful with is the way we word our questions. If we're performing a sample survey, that means we're going out, we're asking questions or a question of our population. So the wording can play an important role as to what responses you get. So if you have a confusing or a leading question, you're going to produce bias in your results. So you might have a perfectly collected sample, but the wording of your question invalidates your findings. So when you ask your question, some things to kind of keep in mind. Keep it concise. So don't make it too wordy. The longer it becomes, the less likely people are able to pay attention to the entire thing and then give a knowledgeable response. The other thing is vocabulary. And if it's something that you know a lot about and you're using technical jargon, the people might not understand exactly what you're asking them. Okay, so if you're like an expert in a certain field and you know all of the technical terminologies, then when you ask someone that who's not familiar with your particular field of interest, they have no idea what you're actually asking them. Okay? Also, when you ask a question, you don't want to introduce any sort of extra information that doesn't need to be there. Okay? So here's an example of a question that could be suffering from this type of bias. So the question was, does it seem possible or impossible to you that the Nazi extermination of the Jews never happened? Okay? So, based on the wording of this question, is it very clear as to exactly what they're asking you? Not right off the bat anyway. If you really think about it and you really dive into the question, you could probably figure it out fairly quickly depending on what's going on. But for the most part, this is kind of a confusing question. In fact, when they went out and asked people this question, 22% of people responded possible. So they said, yes, it's possible that the Holocaust never happened. Because they don't understand what the question is actually asking. When they say possible versus impossible, they're not taking the time to think through what those answers mean. So the way they worded it was confusing, which led people to maybe answer it incorrectly. Now, when they reworded the question and went back out and asked those same people, only 1% of people responded possible. So when you word your question, when you're coming up with what question you're going to ask, make sure it's something that people can understand. It's not too technical. Make sure it's not confusing like this particular question. And then make sure that you're not also leading towards a certain response. So given the fact that guns kill millions of people every year, should the government come take our guns? You're adding extra information that doesn't need to be there, right? So if you're adding extra information in, you're pushing people towards one answer versus another. So when you're asking the question, you ask it and be done. No extra information needs to be involved. Now, if you are going to add in extra information, you need to make sure you have both sides of the question represented. So if there's a negative and a positive side to the question, you need to have both represented if you're going to introduce any extra information. If you only represent this negative, you're going to push people towards the negative response. If you only represent the positive, you're going to push people towards that positive response. So the best thing is to simply leave out the extra information and just ask the question, let them answer based on their knowledge. Does that make sense? All right. Now let's talk about some bad sampling techniques. If you see information that comes from any studies that use the following techniques for sampling, you should throw this stuff out immediately. It's not going to be anything worthwhile. If you are ever working on a research question and you sample using any of these methods, you might as well throw your own work out once you're done, because it's not going to tell anybody anything useful. Okay? So, the different types. The first, voluntary response sampling. So voluntary response is when individuals choose to participate based on a general appeal. So with voluntary response, you are not actually selecting a sample to use. What you're doing is you're posing a question saying, if you want to answer, come do it. So then anyone who feels like they want to respond to whatever question you happen to ask, they're going to come in, respond to your question. But you're not physically choosing the sample. You're just letting people randomly decide whether they want to come up and talk or not. Okay? So, normally, when you allow voluntary response sampling to occur, you are going to get people who have very strong, often negative opinions that are most likely to show up or respond. So when you're looking at a voluntary response sample, when you're allowing the people to decide whether they become part of your sample or not, most often you're going to get people that are responding in the negative. If you think about the two emotions between positive and negative, which one's generally stronger or drives you to do something more? It's generally the negative. Okay, if you're pleased with something and how it's going, you're pleased with how it's going, right? And you're not going to say or do anything really about it. But if it's something that is upsetting you, that's something that you feel needs to be changed, you're more likely to respond, to become active with whatever is happening at the time, right? Negative feelings often lead us to act more so than positive feelings in terms of responding and trying to make change. So when you ask for voluntary response samples, most often, if not always the case, but most often you're going to receive a negative slant towards your responses. So some examples of voluntary response sampling. You have call-in radio shows or call-in TV shows. You have internet surveys. Okay, it could be something where you want to get a sample from a group of kids here at school, so you just post up a table in the cafeteria during lunch, and you post the question and say, if you want to answer, come answer. Okay, so you're just going to let whoever wants to come up and answer the question, how they feel, what their opinion is, whatever it might be. That's voluntary response, and it's bad. Now, one thing to note here, because what sometimes happens is people mistake this voluntary response with this idea of non-response. When I go out and I collect a sample, if I have chosen my sample and I go out and ask the people my question, if they choose not to respond, whether they choose to respond or not, that is not voluntary response. I've chosen them as part of my sample. So they didn't choose to be part of the sample, I chose them to be. They have the option of responding or not. Does that make sense? With voluntary response, you have absolutely no part in choosing the sample itself. You are simply posing a question, and anybody that wants to be part of the sample can become part of the sample. You guys see the difference there? So if it's something where, and so the other thing there is when you talk about voluntary versus non-response, non-response is you chose the sample, they chose not to respond, or a large portion of your sample chose not to respond, which might lead you to go back and select a new sample and hope for better results the next time. Voluntary response, you have no part. It's just come answer if you want, and that's it. So this is bad, do not use it. This actually has its own type of bias. It's called voluntary response bias. So that's another one you might want to add to that list. Undercoverage, non-response, response bias, wording of the question, and now voluntary response bias. So you see results that came from a voluntary response sample, toss them, because they're garbage. Okay? The other type of bad sampling is called convenience sampling. And convenience sampling is exactly what it sounds like. You choose your sample by simply choosing individuals easiest to reach. So that'd be like me trying to find the average height of high school students. And instead of actually going through and collecting an actual sample, I might just say, well, I'm just going to measure my classes because they're easy to get to. That's a convenient sample. I'm not putting any real thought or any real random process to my sampling method. I'm just simply choosing people I know I can get access to easily.
I have a question for voluntary response.
Yeah.
If like you were to post the lunch table, like a table out in the lunchroom, but you said if you want to come answer a question, but you don't tell them the question, and like you just get volunteers, is that still? It's like if they just want to help and help.
It's still not good. It's still not a great way to do it because you're not technically employing randomization. So in order for it to be considered a good representative sample, you still need to be the one producing the sample itself, not allowing the sample to choose itself. Does that make sense?
Yeah.
So yeah, even if they don't know what the question is per se, you're still probably only going to be getting a certain type of person responding, which is still going to probably bias your results. Okay. So convenient sampling, choosing those who are easiest to reach. Now, the reason this one's so bad is that most often it results in undercoverage. So when you use convenient sampling, more often than not, you are going to be suffering from undercoverage. You are going to be missing out on some part of your population. So an example for this would be something like mall surveys. Or you might just go out to, I don't know, you might just stand at a certain busy intersection and just ask people as they're driving by something. It just depends. It's just you're choosing a location and you're just asking people at that location. There was no randomization employed. There's no thought to what you're doing. It's just, I know I can get access to people here, so I'm just going to do that. You go sit at a restaurant, and as people come in, you just ask them questions as they come in. Things like that. Those are convenient samples. Okay, so those are going to produce samples that are most likely going to result in undercoverage. So those are not good as well. In order for it to be a good sampling method, it has to employ some form of randomization. So the ones that we're looking at, SRS, stratified, cluster, systematic, those are ones that you'd want to use. Okay with that? All right. So here's your assignment. Now make sure when you answer these questions today, especially the ones here in the book, you need to make sure that you are giving a full explanation for your answer. These are not questions that you can simply give 1 or 2 word answers in most cases and simply call it good. Now in some problems, all they're going to ask is, given this scenario, what type of sampling was utilized or something like that, then yeah, just tell me what type of sampling was used. But if they ask for a specific type of bias, you need to talk about what bias it was and how you know it was included. How did you know that that bias was there? Or here's a scenario, what forms of bias might they run into? So there you have to give an explanation. So give detailed explanations as to why you're choosing what you're choosing on these problems. Okay. Keep in mind, tomorrow is a review day. So basically, you'll have time to ask questions. You'll have time to work a little bit. Now, this is a fairly long assignment, so you do not want to save this until tomorrow. Try to work on it in class and then finish it up later, because you're also going to get a review assignment tomorrow. So you're going to get an assignment that puts all of 4-1 together to review for the quiz on Friday. So don't put this off. Try to do some of it tonight. Work on it tomorrow so that way you can finish it up. Be ready to work on the review to get ready for that quiz on Friday. Okay?